So every non-zero number raised to the power of 0 is 1. What does it mean to be a non-zero number? What's the one?
A number that is zero.
Yes. So there's only one problem. There's only one problem here, and that's when I have 0 as the base. If 0 is not the base, but the power is 0, it's equal to what number?
1.
1. Okay. We say it's undefined or indeterminate if 0 is the base. And we'll talk about that in a minute. So every non-zero number raised to the power of 0 is 1. Let's continue our pattern here. We'll bring it over here. We have 2 to the third is 8. 2 to the second is 4. 2 to the first was 2, and I tricked some of you on this. 2 to the 0 was 1. Now, let's apply that to the next one. What's 73 to the 0? What's 2,343,000 to the 0? What's 0 to the 0?
0.
Neither. What does the definition here say? Every non-zero number. What's the problem here? It's a 0. So this is actually the one undefined case. For your purposes, just write undefined. I'm not going to explain what indeterminate is here. Okay? Now, let's go back to our table over here and see if we can continue the pattern. So one of our learning targets was to understand that anything that's not 0, but raised to the 0 power equals 1. Okay, that's pretty easy. Now, what about negative powers? What do I do next here? Continuing the pattern, I went from 8 to 4 by dividing by 2. Right, Max? Yeah. Divided by 2 to get to 2. Divided 2 by 2 to get to 1. What do I do with the 1 to get 2 to the negative 1? No, good guess, but we continue the pattern. We keep dividing by 2. So I'm going to take 1 and divide it by 2, and this equals actually 1/2. It does not equal a negative number. It'd be like if I were playing golf, and I only get halfway there each time. The numbers, the distance I hit it would get smaller, right? But it's never going to be a negative number. What's the next one going to be if I continue this pattern? 1 over 4, good. 1 over 4. How did we get that, 1 over 4? It's 2 times 2 is 4, yeah. And then 1, 8, good. So let's come back over here. So that's our, I like to write it vertically like that, but over here we have 2 to the negative 1 was the same as 1 over 2. 2 to the negative 2 was 1 over 4. Look at the connection here. And then 2 to the negative 3 is 1 over 8. Do you see the connection? Horizontally here. Horizontally here. What's the connection? How do the negative powers compare to the positive powers?
They both have the same one.
They have the same number involved, but where is that number?
On the bottom.
On the bottom, where we say it's in the denominator of the fraction, right? So write this down, please. Negative exponent tells you to switch the location of that base and make the exponent positive. So notice none of these are negative numbers. A negative power doesn't give me a negative number. A negative power in each of these gave me a fraction, right? It actually gave me the reciprocal of what I started with over here. You guys remember what reciprocal of?
That's the opposite.
Not opposite.
It's the fraction of the...
It is a fraction. It's a fraction that's flipped. So the fraction here is 8 over 1. 2 to the negative third was 1 over 8. Okay, so it's another way to define negative powers is they take the reciprocal of whatever you're taking the power of. Yeah.
So on the back, there is 7 negative 1. Would that be 1 over 7?
Would be. So I'll let you finish writing that down, and then we'll look at the back side here. Yeah. Okay. Gotta get caught up here when we come back. We gotta keep going. All right, you guys ready to look at the back side? Look at some examples. Okay, this way. Okay.
There's 2 negative 4, 1 is 16. Okay, got it.
Okay. Let's look at the backside. You guys are ready to go here. Okay, 9 to the negative 2 would be the same as 1 over 9 to the positive 2, which is 1 over 81. You are correct. Okay. But first, we need to think in terms of rewriting it. So 9 to the negative 2 is the same as 1 over 9 to the positive second power. What about 7 to the negative 1?
1 over 7.
1 over 7 to the first. You don't need to write the first power. Can we apply this to algebra? X to the negative third would be the same as what?
1 x third.
1 over x to the third. That's right. Okay, good. 2 to the negative fourth would be the same as
1 over 16.
1 over 16. I'm going to write an intermediate step here. 1 over 2 to the fourth, which is 1 over 16. Please be careful here. I see a lot of students multiply the base by the power and will write 8. It's not 8. 2 to the fourth means 2 times 2, which is 4, times 2 more, which is 8, times 2 more, which is 16. So you need to be careful with that. Even teachers do that sometimes. They just kind of look at it quickly and do it. So what about here? Negative 4.567 to the 0. Okay, as long as it's non-zero, yeah. All right. Now let's apply just these 2 rules. This is the rule for 0 exponents and the rule for negative exponents. We're going to apply these to algebraic expressions. So what makes this algebraic is that it has letters in it, okay, not just the number 5. It's a mixture of letters and numbers. So first of all, we need to understand that the power on 5 is 1. Okay, it's not written, but it's there. So what I typically do with expressions like this is maybe just draw a fraction line. Some of these terms are going to stay on the top of the fraction. That's if their power is positive. And some of them will move to the bottom. So this will become 5 will stay on the top. What else stays on the top? A stays on the top. Why?
Because it's positive.
Positive power. And then what happens to b to the negative second?
On the bottom.
And becomes positive power. B to the second. So that is an algebraic simplification. You need to do nothing else. That's it. Simplified exponential expression in algebra means no 0 powers and no negative powers in your answer. Do you see any 0 powers in my answer?
No.
Do you see any negative powers?
No.
No. Okay, but here we do have one. Okay, the next one. What's this going to be? If I just draw a fraction line, what's going to happen here? Yeah, what about the 1? Where does the 1 stay? It stays on top. What do I have on the bottom here? Is it just 0 or?
X is big. I don't know, it's 1.
It's still a 1 on the bottom. There's an unwritten 1, so it's just x to the 5th is how you would see it written. Okay? But, guys, when I do this, I'll just draw the little fraction bar and start moving stuff to the appropriate place. Okay? If it's a negative power in the bottom, it goes to the top. If it's in the top, it goes to the bottom. Notice that nothing else moved. Just the thing where the negative power is attached. All right, I think this is the last example in your notes. It says, what is the value of 3s to the third t to the negative second if s equals 2 and t equals negative 3? So I'm going to substitute in 2 for s and negative 3 for t. So that's what I have. I've substituted in, I put them in parentheses showing that I'm substituting them in. And now I'm going to rewrite this thing, because this isn't, well, this is algebra. Once I put the numbers in, it's now arithmetic. It's no longer algebra. So I'm going to find out what number this is equal to. First thing I'm going to do is draw my fraction bar. What bases stay up on the top? Yeah, Joseph.
3s30.
Okay, but I replaced s with 2. So 3, 2 to the third. And what moves to the bottom? The negative 3. And it should be noted that it moves to the bottom because of its negative power, not because the base is negative. All right, so we've got 3 times, okay, what's 2 to the third equal? We have that up there already. 2 to the third is? No? Well, that's where we're headed, yes. But 2 to the third is 8. Okay, 2 times 2 times 2 is 8. Negative 3 to the second is positive 9, yeah. And so I end up with 24 over 9. So that's just 0 and negative powers. We'll have some practice on that tomorrow,
It's like,
of course.
it tells you the
Are you stamping us?